Good day to all you wonderful viewers out there. I welcome you again to another lesson. Today we'll have a math lesson for you. I am Mr. Cisse and I will present on the topic quadratic functions. Quadratic functions is under a branch of math called algebra, and it's a very important topic for senior secondary school categories, students, level. We will deal with the following. That is the table of content. Start with the key terms. Then from there we'll look at the characteristics of a quadratic functions. Combining transformation, that is part of the introduction. Then we'll do some graphing of quadratic functions. From there, then we'll do problem solving on the quadratic function using graph. The topic is very, very important, quadratic functions. It is a topic that can help you a lot in the area of physics, in projectile bodies, and other fields in economics, that of calculating the profit or the profitability of a particular project, program or product, and in various fields different from that as well. So it's a very, very important topic. We have what we call the prerequisite of a quadratic equation. Prerequisite here means topics that if you've covered, you'll stand a better chance to understand this particular topic very well. They are as follows. Simplifying algebraic expression. Simplifying here means you should be able to collect like terms, and you should be able to differentiate what are like terms and what are unlike terms. Factorizing algebraic fractions. You should be able to factorize and simplify an algebraic expression. Simplifying square roots. That means you should be able to solve a square root problem. Solving linear equation, and graphing linear fractions. These are all prerequisites, and they are more than this. But if you've covered this in your previous lesson, definitely you'll stand a better chance to understand this topic. But nonetheless, even if you did not cover this topic, I will try my level best today to explain to you to a point that you will really understand this particular topic. Key terms. It's very important for you to be able to differentiate and distinguish between quadratic equation and that of quadratic functions. Quadratic equation is any equation that can be written in this form, that is the standard form of the writing a quadratic equation. That is ax squared plus bx plus c equal to 0. This is an equation because it's equated to 0, where a, b, and c are real numbers, and the value of a, that is the coefficient of the quadratic term, is not equal to 0. Ax squared plus bx plus c equal to 0 is the standard form of writing a quadratic equation. It is a quadratic equation because we have the quadratic term, which is x squared, and then we have the linear term as well. The coefficient of the quadratic term, that is this a, must not be equal to 0, because if it is equal to 0, then the whole equation ceases to be quadratic. So the emphasis is this a must never be 0 for it to be a quadratic equation. We have an example there for you. 3x squared plus 5x minus 12 equal to 0. This is an example of a quadratic equation. But sometimes it can be in another form, but this x squared term must be there for it to be a quadratic equation. For that of a quadratic function, any function that can be written in the form y equals to ax squared plus bx plus c, where a, b, c are real numbers, and a is not equal to 0. So we can see the relationship. Ax squared plus bx plus c is in both of them. But for that of equation, it's equated to 0 because we are solving for the exact solution. Equation, we look for two answers of the quadratic function, and those two answers are exact solution to the equation. But for that of a function, we have series of x values that we'll input in so that we can get the graph and we draw the curve of the function. So in that case, you equate the equation to y instead of to 0. So the function, we have y equals, or f of x equals to, sometimes it's written in this form, we have f of x which is a function, is equal to ax squared plus bx plus c. It's either in this form or in this other form. The y there will create values of x. Y will input in the y and generate a lot of y values. Then we use the x and y values and plug the curve. So that's the difference between an equation and that of the function. Quadratic equation, we equate it to 0 and solve for the two exact solutions. A quadratic function, we create a function and give different inputs, and that will generate outputs for us to draw the curve. So you take note of the two terms there. Another key term that is not mentioning is a parabola. Some of you, this might be the first time that you hear this word. Parabola, this is the curve result of graphing a quadratic equation. Anytime you draw a quadratic equation function, you either get a parabola that opens upward, that is this curve that you see, that opens upward is what we call a parabola, or it opens the other way around, downward. This kind of shape is what we call parabolic shape. So this is the parabola that we see there. So it's important that you know that a quadratic equation always will generate a shape of this nature. Another key term that is worth mentioning is the zeros of a function. What are zeros of a function there? An x value that makes the function equal 0. Also called the root of the function, the solution of the function, or the x-intercept of the function. All this referring to the same thing. The zeros of the function, they ask you to find the zeros of a function, or they ask you to find the roots of the function, or of a function, or solve the solution, or that of the x-intercept referring to the same thing. It's very important. What are the zeros or the roots or solutions or that of x-intercept of a quadratic function? These are the points where the parabola cuts the x-axis. We have the x-axis here. This line, do you see here? Can extend. That's the x-axis. And if you look at the parabola that we have there, the blue lines, blue curve, this is the parabola. Where it cuts the x-axis, those 2 points are what we call the solutions to the function, or the roots of the function, or that of the x-intercept, because the intercept with the parabola, where the parabola intersects with the x-axis. So these 2 points are the solutions. So in other words, the graph that we have there, here, if I should ask you what are the solutions to this graph, you should be able to give me their what? Solutions are when x is equal to either what? 1 or what? What's the next solution? Or negative 4. The roots of these quadratic functions are 2. These are the points that the parabola cuts the x-axis. If you look at this particular graph, you realize that there are these 2 points. The blue marked here, which is equal to 1 there. And we have another point here, which is equal to negative 4. These 2 points are the solution to this graph. They are also the x-intercept of the curve. So if they ask you to find the solution of a particular graph given, you have to take the values of these 2 points where the parabola cuts the x-axis. They are the solutions to the equation. We move on to the next one. Another key term that is worth noting is vertex. The vertex is the highest or the lowest point of a parabola. A parabola that's open upward, the vertex is the lowest point of that parabola. And if you have a parabola that opens downward, then the vertex is the maximum point that you can get there, and that is at this point there. So the vertex is always the minimum or the maximum point of the curve, parabolic curve. So we have what we call the minimum value. The minimum value, the y value of the vertex, if A is greater than 0 and the parabola open upward. That if you have a parabola like this, the minimum value that you can get will be at this point on the y-axis. That will be the minimum value of the y value. So at this point, we get the minimum value of the parabola, of the curve, of the function. And if it opens downward like this, then we get the maximum point on the y values like that. So these are the 2 points that are worth noting. And at that point, we say that if you have standard form of a quadratic function, which is ax squared plus bx plus c equals to 0, at this point, you realize that this a there, you're able to determine whether it's a minimum curve or that of the maximum curve. Whether the value that you get will be a minimum or that of will be a maximum. So whether this a greater than 0 means a positive point at that point, and that of a negative point at that point. So if a is positive, what will you get? You will get a minimum point. And if a is maximum, then the a value there will be, the a term will be negative. That's what it means. This quadratic term, the coefficient of the quadratic term, is positive. If it's positive, then we get a minimum. That means we'll get a parabola that will open upward. And if it is a positive value, we'll get a maximum point that will open the other way around, downward. So we continue on the next slides. We have another one called the axis of symmetry, or sometimes called the line of symmetry. Okay? The vertical line that divides a parabola into two symmetrical halves is what we call the axis of symmetry. There is a line that creates two mirror image. Parabola is a curve. The line that divides the parabola into two mirror image is what we call the line of symmetry or the axis of symmetry. So it's also good to note this, that this line that divides the parabola into two halves is what we called the axis of symmetry. We now move to another subheading that is explaining the characteristics of a quadratic function. We've done the key terms, so you should be able to know what a parabola is, what is the vertex, what are the minimum points and of the maximum point. And from there, then we'll explain some key characteristics of a quadratic functions. It's important you take note because these characteristics sometimes very important to remember. Characteristics of a quadratic functions. Remember, a quadratic equation is any equation that can be written in the form ax squared plus bx plus c equals to 0, where a, b, and c are real numbers, and a is not equal to 0. I've explained this previously. So what I want you, we have a question for you there. Question 1, is 2x squared equals to x plus 4 a quadratic equation? Remember, I said there, a quadratic equation is any equation that can be written in the form ax squared plus bx plus c equals to 0. Is this particular equation in that form? Yes, it's a quadratic equation in the sense that if you look at this, you can write this in this form. We have, for equation to be quadratic, we must have something like ax squared plus bx plus c equal to 0. That's a quadratic equation, the standard form of writing a quadratic equation. This particular one is not in the standard form of it, but we can write it to be in this form. That is, we will transpose the x and that of the plus 4 to the left side of the equation. That is, you will have 2x squared. If you move the 4 from the right to the left, it will be negative x. And if I move this positive 4 to the left side of the equal sign, we'll have negative 4 equal to 0. So it's a quadratic equation. We have the quadratic term, we have the x term, and then we have the constant. So this is a quadratic equation. So the first part of the question here, question 1, is 2x squared equals to x plus 4 a quadratic equation? Yes, it's a quadratic equation. Question 2 is 3x plus 4 equals to x plus 1 a quadratic equation? Is 3x minus 4, which is equal to x plus 1 a quadratic equation? You can always go back to what a quadratic equation is. A quadratic equation is any equation that can be written in the form ax squared plus bx plus c equal to 0, where a is not equal to 0 and a, b, c are real numbers. So if you look at this particular one there, is it a quadratic equation? By looking at this, let's collect like terms and see whether we're able to get the quadratic equation. We have 3x minus 4 equals to x plus 1. We said for an equation to be quadratic, we must have it in this form, that is ax squared plus bx plus c equals to 0. What we have here is 3x minus 4 is equal to x plus 1. If we collect like terms here, we're able to see whether it's a quadratic equation or not. I will transpose this x to the left-hand side of the equation, and then transpose this negative 4 to the right-hand side of the equation. That will give us 3x minus x is equal to 1 plus 4. Subtracting, we'll have 2x. Oh, it's unnecessary. Sorry, it's not necessary. Let me go back on that. Equation 2 is 3x minus 4 equals to x plus 1, a quadratic equation. For this to be a quadratic equation, it must be in the standard form of a quadratic equation. That is, we must have ax squared at least for it to be quadratic. So we'll look at this. Let's solve it and see. We'll move all these values on the left-hand side, right-hand side to the left-hand side. We'll have 3x minus x minus 4 minus 1 equal to 0. 3x minus x will give us 2x. Negative minus 4 minus 1 will give us negative 5. It's equal to 0. Is this a quadratic equation? Definitely this is not a quadratic equation. The highest power of x that we get there is x to the power 1. And for an equation to be quadratic, you must have x to the power 2. So this is not a quadratic equation, but the first one there is a quadratic equation. So you should be able to distinguish a quadratic equation and from a linear equation. The second one is a linear equation. It's not quadratic. Move on to the next slide. Another characteristic of a quadratic equation is one should be able to write the equation in standard form. I think I've emphasized this. The form ax squared plus bx plus c equals 0 is the standard form of a quadratic equation. The standard form is not unique. For example, we have x squared minus x plus 4 equals 0. It's a standard form of writing this quadratic equation. But this is equivalent to, that means it can be written in this form where we have negative x squared plus x minus 1 equals 0. What do we do to this equation to transform it to this other equation there? By looking at it, you realize that the x squared term here is positive, and the x squared term here is negative. Likewise, all other terms there that we have. So the first equation is multiplied by -1 to get this other one there. So we can say that a quadratic equation can be transformed. It's not unique. It doesn't mean it has to be 1. It can also be simplified, like the second example that we have there. We have 4x squared minus 2x plus 2 equals 0. We can rewrite this in another form, but it will still be a quadratic equation. This is a simplified form of writing this particular equation there. If we divide each term here by 2, the equation will be simplified to this form. And they are both quadratic equations. We have another sort of an exercise for you. Practice writing quadratic equation in standard form. Simplify if possible. One there, we'll write 2x squared equals to x plus 4 in standard form of a quadratic equation. We are asked to write 2x squared equals to x plus 4 in standard form. First, we have to know what they mean by standard form. Standard form of a quadratic equation. The standard form of a quadratic equation, I've explained it here, was in the previous slides. That is ax squared plus bx plus c equals to 0 is the standard form of a quadratic equation. If you are given an equation that is not in standard form and they ask you to transform it or to write it in standard form, what you will do, look at the equation given and you transpose the values that you have on the other side to one side of the equation and see whether it will be in the standard form of the quadratic equation. The one that we have there, let me solve it for you. The first example, we have 2x squared is equal to x plus 4. If I transpose this x to the left-hand side of the equation, I'll get what? 2x squared minus x is equal to 4. Likewise, if I move the 4 from the left to the right side of the equal sign, the sign will change, so I'll get 2x squared minus x minus 4 is equal to 0. This is in standard form. Because we have a quadratic term, we have the linear term, and we have the constant. This is the way we write an equation, quadratic equation in standard form. Another example. Write 3x equals to negative minus x squared plus 7 in standard form, if possible. We are given another equation and we have to write it in standard form. What do we do to write this in standard form? To write this in standard form, we must be able to recall quadratic equation in standard form. To write a quadratic equation in standard form, the equation must be in what form? Ax squared plus bx plus c equals to 0, where a is not equal to 0 and a, b, c are real numbers. This is the quadratic equation in standard form. So we have to transform this particular equation to the standard form of writing a quadratic equation. So by looking at this, what do we have there? We have 3x is equal to minus x squared plus 7. The quadratic term is x to the power 2. If I move that to this left-hand side of the equation, I'll get x squared plus 3x is equal to 7. If I move the constant again to the left-hand side, we'll get x squared plus 3x minus 7 is equal to 0. This is in standard form. We move to the next slide. Write 6x squared minus 6x equals to 12 in standard form, and simplify if possible. So we have another equation here that is 6x squared minus 6x equals to 12. We have to write it in standard form and simplify if possible. So we'll look at this particular equation. Is it in standard form? For quadratic equation to be in standard form, it must be in the form of ax squared plus bx plus c equal to 0, where a is not equal to 0 and a, b, and c are all members of real numbers. By looking at this one that is given, this equation, it is not in standard form. So we have to write it in standard form. So I'll take it down and solve it. We have 6x squared minus 6x is equals to 12. To write this in standard form, what do we need to do? We'll move this 12 that is on the right-hand side of the equation to the left-hand side of the equation. That will be 6x squared minus 6x minus 12 is equal to 0 then. This equation is in standard form, but it is stated that simplify if possible. So this particular equation, we'll look at it. Can we simplify this further? Is it possible for us to simplify this further by looking at the coefficients and the terms that we have there? Yes. If you divide each term here by 6, we'll get this equation in simplified form. So we have 6x squared minus 6x minus 12 equals to 0. If we divide through by 6, each term by 6, we realize that we'll end up getting something like x squared minus x minus 2 equal to 0. This is in simplified form of this particular quadratic equation. So it's this one we are able to simplify because we have common factors, that is 6, 6, and 12. So if you have a quadratic equation that is in standard form and can be simplified further, it's better you simplify and get a quadratic equation of this format. We move to the next slide. Write 3x minus 2 equals to 5x in standard form. We have to write 3x minus 2 equals to 5x in standard form. The first and most important thing to ask yourself question is this in standard form? Is the equation given in standard form? We have 3x minus 2 equals to 5x. This particular equation, for an equation to be in standard form of quadratic equation, we must have the x squared term. And we don't have x squared term here. If we should simplify this further, we'll get something like 3x minus 5x minus 2 equal to 0. If we subtract, we'll get negative 2x minus 2 equal to 0, which can be simplified further to negative x minus 1 equal to 0. This is a linear equation. It's not a quadratic equation. So since it's a linear equation, then the issue of writing the standard form we should not even bother because it's not in quadratic form. It's not a quadratic equation. This is a linear equation, not quadratic. Similarly, similar to quadratic equation, the standard form of a quadratic function is y equals to ax squared plus bx plus c, where a is not equal to 0. So the standard form of writing a quadratic equation is the same as standard form of writing a quadratic function. Whatever function, always equated to y, and that of the equation we equated to 0. But it's worth noting that it says note, a can be negative or positive. The quadratic term that we have there, the quadratic term, if you look at it, we have y equals to ax squared plus bx plus c. The quadratic term, which is the x squared term, the value that we have in front of it, that's the coefficient there, can be negative, it can also be positive. If you look at the first example that they give there, y equals to negative 3. Negative 3 there is negative. X squared plus 4x minus 10. This is a quadratic function, and the a term there we have, it's negative, but it's still quadratic. The second example, y equals to 5x squared minus 9 is a quadratic equation, but it's not written in standard form, but it's quadratic equation. The coefficient that we have there for x squared term is positive. Similar to quadratic equation, the standard form of writing a quadratic function is y equals to ax squared plus bx plus c, where a is not equal to 0. That is a quadratic function. Quadratic function and that of quadratic equation, they are all, the standard form of it are all similar, the same. The similarity is we always have this ax squared plus bx plus c as the quadratic term, that is the a squared term, that is the standard form of writing it. So what you need to take note here is the first term, that is the x squared term. The coefficient can be negative, it can also be positive. This is why it's the notice that a can be a negative value, it can also be a positive real number. The examples are here. The first example of a quadratic function, y equals to minus 3x squared plus 4x minus 10 is a quadratic function. This particular quadratic function, the a, that is the coefficient of the quadratic term, is negative, negative 3. The second example, the coefficient of a quadratic term is 5, and that 5 is positive, 5. Likewise, that of the third example, we have y equals to x squared. This y equals to x squared, this x squared is a quadratic function. So the coefficient that we have in front of the x is 1, even though 1 is not written there. But it's still quadratic. The last but not the least is another function, that is y equals to 1 over 4x squared plus 5x minus 12. This is also another quadratic function. The coefficient of the quadratic term is 1 over 4, which is a fraction, and it's positive. So we can either get a positive or that of a negative value as our a value. But whether it's positive or negative, it's still a quadratic function. The only time it will not be a quadratic function is when the coefficient there is 0. Then it will not cease to be quadratic. Graph. When graphed, a quadratic function will have the shape of a parabola. I've explained this before. A parabola will open upward if a is greater than 0, or downward if a is less than 0. What do they mean by that? The parabola, that is the shape that we have there, the blue one, the curve, and that of the pink one there, it will open upward. That is that of the pink one there, curve there, if the a term is positive. The coefficient of the quadratic term is positive. It will open upward. And it will open downward, that means if the a term is negative. So the coefficient of the quadratic term is very important in determining the shape of the parabola. The parabola will open upward if the coefficient of the quadratic term is positive, and it will open downward, upside down like that, if the coefficient of the quadratic term is negative. The domain the domain of a quadratic function is all real numbers. Domain of a quadratic function is determined on the x-axis. You look at the values of the x-axis. What values can I input in that will generate an output for me? For the domain of a quadratic function is all real numbers. That means it's from negative infinity to positive infinity. Any value that you input in, you're able to get an output on the y value. Because if you look at this parabola, the parabola is expanding. And it's expanding on the left and to that of the right. On both sides, it's going to positive, negative. On the left side, it's going to negative infinity. On the right side, it's going to positive infinity. So any x value that we pick, we're able to generate an output. So in that case, the domain will be from negative infinity to positive infinity. Let's take an example. Let's take this particular point here. This point, the x value there is 0. So when x is equal to 0, if I should input this in this function, this quadratic function, it will give us an output. The output will be y is going to give us 2. If I input in 2, that is when x is equals to 2, we'll get an output of y will be equals to negative 6. So any real value that you pick on this x-axis will generate an output on this quadratic function. So in that case, the domain is all real numbers. All real will include from negative infinity to positive infinity. And domain for all quadratic functions is from positive infinity to negative infinity. We now move on to range. To determine the range of a quadratic function, ask yourself 2 questions. Is the vertex a minimum or a maximum? What is the y value of the vertex? Because if a vertex is a minimum, if the vertex is a minimum, then the range is all real numbers greater than or equal to the y value of the vertex. That is, if we look at this particular graph given there, we have the vertex there is a minimum. Why is it a minimum? If you look at this point here, this is the vertex point. This point is the lowest point of this quadratic function. And the value for it is negative 6. Negative 6 is the lowest point that we can get, an output that we can get from this particular function. So the range is determined by on the y-axis, not the x-axis. The domain, we look at the domain on the x-axis. For the range, we calculate the range on the y-axis. So the minimum point that we can get from this is negative 6. And the maximum is positive infinity. So the range is from here, this point, all the way to positive infinity. So this is why the range is given here. For a minimum, the range, let me go over this again. The range of this quadratic is from negative 6 to positive infinity. Negative 6 there is close because that's the lowest. You cannot go beyond that. It's the minimum point that you can get, negative 6 to positive infinity. That will be the range of the quadratic function. We move on to the next one. Next. If the vertex is a maximum, what do you mean by that? Maximum there, it means the vertex is the highest point on the curve. Then the range is all real less than or equal to the y value of the vertex. That is the maximum point that we can get there. That is 10. So the range of the quadratic equation is from negative infinity on the y-axis all the way to positive 10. This is why it is written here, the range of the quadratic is negative infinity to 10. Negative infinity there is not a number, so it's open. We don't know the final number there. But for 10, we know is the maximum point that we can get. So there it's close. The axis of symmetry. An axis of symmetry, also known as the line of symmetry, will divide the parabola into two mirror image. Okay. The line of symmetry is also a vertical line of the form x is equal to negative b ordered over 2a. This is the formula to find the line of symmetry or the axis of symmetry. So the formula is x is equal to minus b ordered over 2a. By looking at the graph given here, the line of symmetry is this red line that divides the parabola into two equal halves. This particular line divides the parabola into two mirror image, we can see. And to find the axis of symmetry, when the equation is given, there is the equation that is grafted down there. By looking at this equation, we have to use the formula down there, x is equal to minus b, all that over 2a. The value for b in this particular function is what? Negative 8. The value for a there is 2. Value for c is another positive 2 there. So if you have to solve this equation there, we have to substitute the values of b and a. The value for b is negative 8, so in place of 8, we put there negative 8. So x equals to negative, in bracket, negative 8, all that over 2, in bracket, the value for a, which is 2, we substitute it there, then we solve. Negative, negative will be positive, so at the end we'll have 8 divided by 4, which will give us 2 down there. So the line of symmetry, come to the graph, 2 on the x-axis, where x equals to 2 is this point there. So you draw a vertical line at that point to determine the line of symmetry. That will give us the line of symmetry at that end. The x-intercepts are the point at which a parabola intersects the x-axis. These points are also known as the zeros, the roots, solutions, and the solution sets. It's the same thing. It all means the same thing. Okay? To find the x-intercept is the same as to find the solution to the equation, quadratic function, or to find the roots, or to find the zeros of the quadratic function. Each quadratic function has one or two or no real solution. Let's look at the example given there. If you look at the blue one down there, there is no solution. Why is it that there is no solution? Because the curve doesn't even cut the x-axis at all. Because it doesn't pass through the x-axis, it has no solution, no real solution at all. The pink one that we have here, this parabola here that's open downward, will have two solutions. Solution at this point, 2.2 and a quarter there, and minus 3.75, sort of. These 2 points will be the solution to this particular curve. So it has two real solutions. For this one, no real solution. The third one there we have, it has only one solution. That is, it cuts the x-axis at only one point. And that point is 3. Sorry, at 5. At 5, it cuts the x-axis. And it's only at that point. So there's only one solution for this one. If the parabola is in this form, there's only one solution. If it is in this form, no real solution. If it is in this form, then we have two real solutions. The solution is determined by the value at the point it cuts the x-axis. Let's try these questions. One there, if a parabola open downward, that is, if you have graph of this nature and then you have a parabola that opens downward, the vertex is the highest value on the parabola, true or false? The vertex is the highest value of the parabola. The vertex for this parabola will be somewhere there. True or false? It is true, because if you look at this, this point will be the highest value that you can get on the y-axis down there. So the correct answer there is true. Question 2. If a parabola open upward, then A is greater than 0, the value for A, B, A is less than 0, and C, A is equal to 0. If a parabola open upward, then A is greater than 0, or A is less than 0, but out of A is equal to A equals 0 is completely out. That is disqualified. So it's which one among them? A greater than 0 or A less than 0? If a parabola open upwards, then the value of A is greater than 0. So A is the correct answer down there. Example 3. The vertical line that divides a parabola into two symmetrical halves is called discriminant, quadratic equation, C, axis of symmetry, D, vertex, and E, maximum. The vertical line that divides a parabola into two equal halves. If you have parabola in this format, the line that divides it into two equal halves, let's say something like that. This line into two symmetrical halves is called what? The correct option there is C. That is axis of symmetry. The line that divides into two equal halves is called the axis of symmetry, or the line of symmetry there. Example 4. Which of the following shows a quadratic equation correctly written in standard form? We have 5 different equations. We want you to identify which one is correctly written in standard form. For a quadratic equation to be in standard form, what do we need? It's in standard form when we have equation of this form, ax squared plus bx plus c equal to 0, where a is not equal to 0 and a, b, c are real numbers. By looking at this, the option A there is not in standard form, because the first term that we have there is not a quadratic term. For a quadratic equation to be in standard form, the first term must be a quadratic term, so it's straight ahead eliminated. This, likewise, that of B is not a quadratic equation. E is not also in quadratic, it's not in standard form of a quadratic equation. So the only two options that can be in the standard form of quadratic equation are C and D. But if you look at C, For quadratic equation to be in standard form, it must be equated to 0. We must have all the three terms equated to 0, and C is not in that form. So automatically the correct option there is D. D there, negative 5x squared plus 3x plus 8 equal to 0 is in standard form of a quadratic equation. All the other options are not in the standard form of quadratic equation. Example 5. What is the equation for the axis of symmetry for the quadratic function y equals to 2x squared plus 12x minus 7? They want us to find the equation of the axis of symmetry. What will be the solution? And the solution, to get it, we must be able to recall the formula to find the line of symmetry, which is x is equal to minus b all that over 2a. If you look at this given function there, our b is 12, positive 12, and our a is 2. If we substitute in place of b 12 and in place of a 2, then we're able to find the value for the axis of symmetry. So therefore x is equal to minus in bracket 12 all that over 2 times 2. This will give us negative 12 all that over 4, which will give us what? 4 goes into 12, that will give us negative 3. So therefore, x is equal to negative 3. That will be the lines of symmetry. At this particular point, the parabola for this equation will be divided into two mirror images. So the solution, the correct option there is D, where x is equal to negative 3. Example 6. What is the domain of the quadratic function below? We have to find the domain of the quadratic function below. The domain, as I told you before, is determined on the x-axis. If you look at this parabola, the parabola is open, infinity on both sides. So automatically the domain for this quadratic function is D, which is all of R. The domain is from negative infinity to positive infinity, which is the whole of R. Real numbers. What is the range of a quadratic function below? The range is determined, we find the range on the y values, on the y-axis. If you look at this, for this particular parabola, we have the minimum point. The minimum point there is negative 4, and the maximum is infinity. So if they ask you to find the range here, the range for this particular function is negative 4 to positive infinity. Will be the range of the function. Negative 4 to positive infinity. Viewers, that's the end of this lesson. Next lesson, we'll start with graphing of quadratic functions. So thank you very much for your kind attention. We'll draw the curtain here, and then we'll continue from here in our subsequent lesson. Okay? Don't forget, always regularly wash your hand, clean, and make sure you stay at home. Don't be involved in areas where there are a lot of people. I will stop here for the day. Thank you very much.